Welcome to our exploration of the incredible cells that make up your immune system. Every day, your body is exposed to countless threats, from bacteria and viruses to toxins and other harmful invaders. But thanks to a complex network of specialized cells, your immune system stands ready to defend you. In this video, we'll journey through the main types of immune cells, discover how they work together, and see why each one is essential for keeping you healthy. Let's begin by understanding what the immune system is and why its cellular components are so vital for survival. Immune system is your body's natural defense mechanism. It's made up of a network of cells, tissues, and organs that work together to protect you from disease. At the heart of this system are immune cells, each with a unique role. Some act as sentinels, constantly on the lookout for danger, while others are specialized fighters ready to attack invaders. Understanding these cells helps us appreciate how our bodies stay healthy and respond to infection. Next, let's look at the two main branches of the immune system: innate and adaptive immunity. Your immune system has two main arms: innate and adaptive immunity. The innate immune system is your body's first line of defense, responding quickly to threats. It includes barriers like skin and mucous membranes, as well as certain immune cells that act fast. The adaptive immune system, on the other hand, takes longer to respond but is highly specific. It learns from past encounters and provides long-lasting protection. Both systems rely on specialized cells to function effectively. Let's start by meeting the key players in the innate immune system. Phagocytes are a group of immune cells that act as the body's cleanup crew. Their main job is to engulf and digest pathogens, dead cells, and debris. The most well-known phagocytes are neutrophils and macrophages. Neutrophils are the most abundant white blood cells and are quick to arrive at infection sites. Macrophages, meanwhile, patrol tissues and can live for months, constantly searching for invaders. Both play a crucial role in the early stages of immune defense, helping to contain infections before they spread. Neutrophils are the first responders of the immune system. When an infection occurs, they rush to the site within minutes, drawn by chemical signals. Once there, they attack bacteria and fungi by engulfing them or releasing toxic substances. Neutrophils are short-lived but incredibly effective, sacrificing themselves to protect the body. Their rapid response is vital for preventing infections from gaining a foothold. After doing their job, they die off, and their remains are cleared away by other immune cells. Macrophages are larger phagocytes that reside in tissues throughout the body. They act as sentinels, constantly on patrol for signs of trouble. When they encounter pathogens, they engulf and digest them, but their role doesn't stop there. Macrophages also help trigger inflammation and alert other immune cells to the presence of invaders. They can even present pieces of pathogens to adaptive immune cells, helping to kickstart a more targeted response. Their versatility makes them essential for both immediate and long-term immunity. Dendritic cells are the immune system's messengers. They capture antigens from pathogens and travel to lymph nodes, where they present these antigens to T cells. This process is crucial for activating the adaptive immune response. Dendritic cells act as a bridge between innate and adaptive immunity, ensuring that the body mounts a specific response to each threat. Without dendritic cells, the immune system would struggle to recognize and remember invaders. Natural killer (NK) cells are a unique type of lymphocyte that play a key role in the innate immune system. Unlike other immune cells, NK cells can recognize and destroy infected or cancerous cells without prior exposure. They patrol the body looking for cells that display abnormal signals and quickly eliminate them. NK cells are especially important for controlling viral infections and preventing the spread of tumors. Their ability to act swiftly makes them a vital part of your body's early defense. Lymphocytes are a major group of white blood cells that are central to the adaptive immune system. There are three main types: B cells, T cells, and natural killer cells. While NK cells are part of innate immunity, B and T cells are responsible for recognizing specific pathogens and mounting targeted responses. Lymphocytes are found in the blood, lymph nodes, and other lymphatic tissues, constantly monitoring for signs of infection. Their ability to remember past invaders is key to long-term immunity. B cells are specialized lymphocytes that produce antibodies. When they encounter a pathogen, B cells are activated and start making antibodies that specifically target that invader. These antibodies circulate in the blood and help neutralize or mark pathogens for destruction by other immune cells. Some B cells become memory cells, remaining in the body long after the infection is cleared. This allows for a faster and stronger response if the same pathogen returns in the future. T cells are another type of lymphocyte, and they play a variety of roles in the immune response. There are several types of T cells, including helper T cells, cytotoxic T cells, and regulatory T cells. Helper T cells coordinate the immune response by signaling other cells, while cytotoxic T cells directly kill infected or abnormal cells. Regulatory T cells help keep the immune system in check, preventing it from attacking the body's own tissues. Together, T cells ensure a balanced and effective defense. Helper T cells are like the generals of the immune system. They don't attack invaders directly, but instead they release chemical signals called cytokines that activate other immune cells. This includes stimulating B cells to produce antibodies and helping cytotoxic T cells find and destroy infected cells. Without helper T cells, the immune response would be weak and uncoordinated. Their leadership is crucial for mounting a strong defense against infection. Cytotoxic T cells are the immune system's assassins. They patrol the body looking for cells that have been infected by viruses or have become cancerous. When they find a target, they release toxic molecules that trigger the cell's death. This precise targeting helps eliminate threats without harming healthy cells. Cytotoxic T cells are essential for controlling viral infections and preventing the spread of cancer within the body. Regulatory T cells act as the immune system's peacekeepers. Their main job is to prevent the immune system from attacking the body's own tissues, a process known as autoimmunity. They do this by suppressing the activity of other immune cells when necessary. This balance is vital for maintaining health, as an overactive immune system can lead to autoimmune diseases. Regulatory T cells help ensure that the immune response is strong but not destructive. B and T cells become memory cells after an infection or vaccination. These cells remain in the body for years, sometimes even a lifetime. If the same pathogen tries to invade again, memory cells respond much more quickly and effectively than the first time. This is the basis for long-term immunity and why vaccines work. Memory cells are the immune system's way of learning from experience and providing lasting protection. B cells are activated, some of them become plasma cells. Plasma cells are specialized for producing large amounts of antibodies which are released into the bloodstream. These antibodies bind to pathogens, neutralizing them or marking them for destruction by other immune cells. Plasma cells are short-lived but play a critical role during active infections, helping to clear pathogens from the body quickly. As cells are found in tissues throughout the body, especially in areas exposed to the environment like the skin and lungs. They play a key role in allergic reactions by releasing histamine and other chemicals when they detect allergens. This causes symptoms like itching, swelling, and redness. Mast cells also help defend against parasites and play a role in wound healing. While they can cause discomfort during allergies, they are important for protecting the body from certain threats. Eosinophils are the rarest type of white blood cell, but they have a powerful impact. Like mast cells, they release histamine and other chemicals during allergic reactions and inflammation. Basophils also help defend against parasites and play a role in regulating blood flow to affected areas. Though they make up less than 1% of white blood cells, their actions are crucial for orchestrating the body's response to certain threats. Eosinophils are specialized white blood cells that focus on fighting parasites, such as worms. They also play a role in allergic reactions and asthma. Eosinophils release toxic proteins and chemicals that can destroy parasites but may also contribute to tissue damage during allergies. Their numbers increase during parasitic infections and certain allergic conditions, highlighting their importance in immune defense. Monocytes are large white blood cells that circulate in the bloodstream. When they enter tissues, they mature into macrophages or dendritic cells depending on the signals they receive. Monocytes act as a reserve force, ready to respond to infections or injury by transforming into the cells needed for defense. Their flexibility and ability to become different cell types make them a vital part of the immune system's adaptability. Granulocytes are a group of white blood cells characterized by the presence of granules in their cytoplasm. These granules contain enzymes and chemicals that help destroy pathogens. The main types of granulocytes are neutrophils, eosinophils, and basophils. Each type has a specialized function, but all are important for the body's defense against infection and inflammation. Granulocytes are usually among the first cells to arrive at the site of infection. White blood cells, or leukocytes, are the main cellular components of the immune system. They circulate in the blood and lymphatic system, constantly searching for signs of infection or injury. There are several types of white blood cells, each with a unique role in immune defense. Together, they form a coordinated network that protects the body from a wide range of threats. Understanding the different types of white blood cells is key to appreciating how the immune system works. While red blood cells are responsible for carrying oxygen throughout the body, white blood cells are dedicated to defense. Unlike red blood cells, which have a uniform appearance and function, white blood cells come in many shapes and sizes, each with a specialized role. This diversity allows the immune system to respond to a wide variety of threats, from bacteria and viruses to parasites and cancer cells. Bone marrow is the birthplace of all blood cells, including those of the immune system. Stem cells in the bone marrow divide and mature into various types of white blood cells, red blood cells, and platelets. The bone marrow ensures a constant supply of new immune cells, ready to replace those lost during infections or normal turnover. Without healthy bone marrow, the immune system cannot function properly. Lymphatic system is a network of vessels and organs that transport lymph, a fluid containing white blood cells. Lymph nodes, scattered throughout the body, act as checkpoints where immune cells gather and communicate. The lymphatic system helps filter out pathogens and supports the movement of immune cells to sites of infection. It's an essential part of the body's defense network, working closely with the circulatory and immune system. Spleen is an organ located in the upper left abdomen. It acts as a blood filter, removing old or damaged blood cells and storing white blood cells. The spleen also helps mount immune responses to bloodborne pathogens. If the spleen detects bacteria or viruses in the blood, it activates immune cells to fight the infection. While you can live without a spleen, its absence can make you more susceptible to certain infections. Thymus is a small organ located behind the breastbone. It's where T cells mature and learn to distinguish between the body's own cells and foreign invaders. This training is crucial for preventing autoimmunity. The thymus is most active during childhood and gradually shrinks with age, but its role in developing a functional immune system is vital. Immune surveillance is the process by which immune cells constantly monitor the body for signs of infection or abnormality. Cells like natural killer cells and cytotoxic T cells patrol tissues, ready to respond to any threats. This constant vigilance helps detect and eliminate cancerous or infected cells before they can cause harm. Immune surveillance is a key reason why most infections and cancers are caught early by the body. Immune cells communicate using chemical signals called cytokines. These signals help coordinate the immune response, ensuring that the right cells are activated at the right time. Communication is essential for mounting an effective defense and for preventing the immune system from overreacting. Without proper communication, the immune response would be disorganized and less effective. Inflammation is one of the immune system's first responses to infection or injury. It's triggered by immune cells releasing chemicals that increase blood flow and attract more immune cells to the area. While inflammation can cause redness, swelling, and pain, it's a sign that the body is fighting back. Chronic or excessive inflammation, however, can be harmful and is linked to many diseases. Antigen presentation is a process where certain immune cells like dendritic cells and macrophages display pieces of pathogens on their surface. This helps T cells recognize and respond to specific threats. Antigen presentation is essential for activating the adaptive immune response and ensuring that the body targets the right invaders. Antibodies are proteins produced by B cells and plasma cells. They bind specifically to antigens on pathogens, neutralizing them or marking them for destruction. Antibodies are highly specific, allowing the immune system to target a wide range of invaders. Their presence in the blood is a key indicator of immune activity and protection. Vaccines work by exposing the immune system to harmless pieces of a pathogen, such as proteins or inactivated viruses. This stimulates the production of memory cells without causing disease. If the real pathogen is encountered later, the immune system responds quickly and effectively. Vaccines are one of the most powerful tools for preventing infectious diseases. Autoimmune diseases occur when the immune system mistakenly attacks the body's own tissues. This can happen if regulatory T cells fail to keep the immune response in check. Common autoimmune diseases include type 1 diabetes, rheumatoid arthritis, and lupus. Understanding how immune cells normally distinguish self from non-self is key to preventing and treating these conditions. Immunodeficiency occurs when the immune system is weakened or incomplete. This can be due to genetic conditions, infections like HIV, or treatments such as chemotherapy. People with immunodeficiency are more susceptible to infections and may have trouble fighting off even common illnesses. Supporting immune function is especially important for these individuals. Immune system plays a crucial role in detecting and eliminating cancer cells. However, some cancers can evade immune detection or suppress immune responses. Immunotherapy is a type of cancer treatment that boosts the body's natural defenses to fight cancer more effectively. Understanding how immune cells interact with cancer is a major focus of medical research. Allergies occur when the immune system overreacts to harmless substances like pollen, food, or pet dander. Mast cells and basophils play a key role in triggering allergic reactions by releasing histamine. While allergies can be uncomfortable or even dangerous, they are a sign of an active, though sometimes misguided, immune system. As we age, the immune system gradually becomes less effective. The production of new immune cells slows down and existing cells may not function as well. This makes older adults more susceptible to infections and less responsive to vaccines. Research is ongoing to find ways to support immune health throughout life. Every day, immune cells work together to keep you healthy. They patrol your body, communicate with each other, and respond rapidly to threats. Whether fighting off a cold, healing a wound, or preventing cancer, these cells are always on the job. Their teamwork and adaptability are what make the immune system so effective. Healthy lifestyle supports the immune system. Eating a balanced diet, getting regular exercise, managing stress, and getting enough sleep all help immune cells function at their best. Avoiding smoking and excessive alcohol also reduces the risk of weakening your defenses. Taking care of your body is the best way to keep your immune system strong. Immunology is a rapidly advancing field. Scientists are discovering new types of immune cells and developing innovative treatments for diseases like cancer, autoimmune disorders, and infections. Advances in immunotherapy and vaccine technology hold great promise for the future. Understanding the immune system's cellular players is key to unlocking new medical breakthroughs. Let's recap the main types of immune cells we've discussed. Phagocytes like neutrophils and macrophages, lymphocytes including B and T cells, natural killer cells, and specialized cells like dendritic cells, mast cells, basophils, and eosinophils. Each plays a unique role in defending the body and maintaining health. Together, they form a powerful and adaptable defense system. Immune cells are essential for survival. Without them, our bodies would be defenseless against infections, cancer, and other threats. Their ability to recognize, remember, and respond to danger is what keeps us alive and healthy. By understanding and supporting our immune system, we can live longer, healthier lives. Every day, millions of immune cells work behind the scenes to protect you. Whether you're aware of it or not, they're always on guard, ready to respond to any threat. Their dedication and teamwork are truly heroic, making them some of the most important cells in your body. As we wrap up our journey through the cells of the immune system, take a moment to appreciate the incredible work these tiny defenders do every day. From fighting infections to preventing disease, immune cells are always at work to keep you safe. By learning about them, we can better understand our health and the importance of supporting our immune system. Thanks for joining us on this exploration of your body's amazing defenders.